Here's some notes about the difference between an arithmetic problem, a linear function, and a system. An arithmetic problem you've seen since you were a little kid. 1 plus 4 is equal to 5. In algebra, we begin with functions where we put in chickens and we get out chicken nuggets. Algebraic equations are all about saying if you put in some value, call it x, you get out a specific number. When we talk about solving an equation, in general, we are asking, well, what's the output given the input? And sometimes we reverse it and say, okay, we've got this sort of output. What was the input that gave us that? A system asks and answers the question, here is a set of two different functions. Do they have anything in common? Do they have a point in common? So, for example, f of x is 2x plus 3. A system might be f of x is 2x plus 3, and g of x, a different function of x, might be 3x minus 2. And we can find out that these two lines intersect at some point. When we are working with systems, we are asking, do these lines intersect? We know from our earlier studies that the lines may intersect in a graph that could look like this, or like that, or I suppose even like that. There is only going to be one point of intersection. Is there always an intersection? No, there's not always an intersection. If we have two parallel lines, two lines with the same slope, these lines are never going to intersect, ever, ever, ever. So we could have one solution, we could have no solutions, and we sometimes talk about an infinite number of solutions. For example, f of x equals 2x plus 3, g of x equals 4x plus 6. When we simplify g of x, we find that it ends up being exactly the same line as f of x, and when that happens, we can graph it as one line, exactly over the same line. For every input, we get the identical output. Then we say there are an infinite number of solutions. So the difference between a function or a linear equation and a system